Hi everyone, thank you for attending our webinar today. Good afternoon or good evening or good morning, depending on where in the world you are. My name is Vikram, and I'm joined on this webinar by my two senior colleagues, Mike Yang and Prasad Maya. Yeah, let's go ahead and get started. The title of this webinar is Wirespeed All IP Packet Capture and Analysis. And so we're very excited to talk to you today about our solution for high-speed packet capture and analysis. So I'll go ahead and get started. Before we dive into this, let's briefly just talk about GL. In case you don't know us, I think many of you on the call are familiar with us, but just in case you're new to GL, we are located in Gaithersburg, Maryland, USA. We have been around for over 30 years. And we are a telecommunications consulting company. And in addition to our consulting services, we also manufacture test and measurement equipment. And we manufacture telecom test and measurement solutions for basically all telecom networks, wireless networks, Ethernet, SONET, SDH, TDM, analog networks, you name it, we have a solution for you. And our solutions are very versatile. You can capture, you can analyze, you can emulate traffic, and you can visualize it, you can store it. Our solutions are portable, they're very cost effective. So no matter what telecom challenge you have, we're very confident that we have a solution for you to help you. So please definitely come and talk to us. We always love talking to customers, and we're very confident we can help you. Okay, so today's agenda, we're going to be focusing on high-speed Ethernet capture and analysis. So we'll first do a really brief overview of Ethernet. Then we'll talk about this whole challenge of doing high-speed capture. As you may know, we have several products such as PacketExpert 10GX, which can do Ethernet testing. We have PacketScan, which is a high-performance protocol analyzer. And we also have a new product which kind of combines both of best worlds of PacketExpert and PacketScan. And we call this new product PacketScanPX. So we'll spend a lot of time talking about PacketScanPX and its advantages. And then we'll talk about NetServer Web, which is a really convenient way to put everything together and do your analysis through a comfortable web-based dashboard. So we've got a lot to talk about, and then we'll do some conclusions, and then we'll take questions. Okay, so Ethernet technology. Ethernet is basically everywhere these days. It has become the dominant layer 2 technology on local area networks, as well as metropolitan area networks, basically everywhere except perhaps the backbone, some backbone networks, but everywhere else, Ethernet is basically taking over. So why is this? Why has this transformation happened? It's because, first of all, Ethernet is very fast. You know, you have gigabit Ethernet these days is standard, 10 gigabit Ethernet all the way up 100 gigabit Ethernet and beyond. So Ethernet is very fast. New standards are always being developed for fiber-based Ethernet and copper-based Ethernet and so on. And Ethernet is very reliable because of its collision detection mechanisms, collision avoidance mechanisms, and so on. So Ethernet is everywhere. A lot of customers come to us asking for Ethernet testing solutions. So we have a very big product line devoted to Ethernet. Okay, now specifically, a lot of customers ask us for high-speed packet capture solutions across Ethernet links. So customers have a lot of different requirements. Some of them are looking to do just network monitoring, make sure the networks are running properly, and so on, and troubleshooting these networks, making sure that service level agreements are being met, quality of service and class of service, and all these other different types of service performance, they need to be able to capture across the network and verify that. Also, some customers come to us for network surveillance purposes, so they need to actually snoop on the traffic, record traffic, record voice calls, and so on. So for law enforcement agencies, recording traffic and recording voice calls is very important to them. So no matter what the application is, many customers come to us and they need high-speed packet capture solutions. And they need to be able to capture a lot of different things. So whether it's voice, video, or data, whether it's TCP, whether it's UDP. TCP is used for data, UDP for streaming voice and video. All sorts of different protocols, right? SIP, RTP, HTTP, FTP, SMB. I mean, the list goes on and on, whether it's email traffic, web browsing, voice over IP traffic, file sharing, all sorts of different protocols. So customers have all sorts of different requirements over, and they're interested in all these different protocols. Furthermore, customers, depending on what type of network they're tapping into, some customers need fiber-based solutions, single mode or multi-mode, or they may need copper-based solutions, so twisted pair copper. Ethernet, of course, is carried over both, and high-speed Ethernet is carried over both. And finally, no matter what the customer is, usually they want to filter on the types of traffic that they're interested in. So they could be interested in specific IP addresses, or specific TCP UDP ports, specific protocols, or perhaps at the individual byte layer of the packet, they're trying to identify certain packets. So they're not always interested in all the traffic that's passing through this high-speed pipe, but they want to be able to filter at wire speed on this traffic. So these are a lot of the different requirements that customers come to us when they're looking for packet capture solutions. Okay, so we have a hardware-based Ethernet testing solution. It's one of our best-selling products. It's called PacketExpert 10GX. And if you look at the PacketExpert, you notice right away that we have a lot of versatile interfaces here. We have these SFP cages that can support electrical or optical connections. And we have both 10, 100, 1000 megabits per second connections, as well as 10 gigabit per second connections. We can do optical or electrical, and it's a very portable device. Okay, this is, you can hold this in the palm of your hand. This is the back of the device. The main thing to notice is the USB connection here. So you control this testing device through the USB connection. So you plug it into your computer, we give you the USB cable, and you're off and running. And you can do a lot of different types of Ethernet testing with PacketExpert. You can do intrusive testing where you're generating traffic onto the network. So things like bit error rate testing, RFC 2544, RFC 6349 for TCP testing, ITU-T Y.1564 for verifying service level agreements, and so on. So it can generate traffic onto the network and analyze that traffic, but it can also be used as a tap. And when it's used as a tap, you can actually record traffic and play it back at a later time. You can also impair the traffic if you wanted to. So any traffic coming in, you can actually impair it if you want to. So PacketExpert can do a lot of different Ethernet testing for you. And we have whole webinars and videos dedicated to PacketExpert. I don't want to go too deep into PacketExpert. I just want to mention that it can do all these different things, and it's all Ethernet-based testing. Okay, so the next product we have is PacketScan. So PacketScan is a protocol analyzer. And I'm not kidding when I show you all these different protocols. It can literally decode all these different protocols on a network. PacketScan, when we originally developed it, it was mainly for like voice call analysis. So whether it's voice calls over the public switch telephone network, or whether it's some wireless calls over a cellular network, or whether it's voice over IP calls, PacketScan can decode all of these different protocols. You can sit it on the network, and basically any position on the network where it can sit and capture traffic through like a monitor port. You can place it there and you can decode all of these different protocols. So PacketScan is our very powerful protocol analyzer. Later on, we're going to talk about NetServer Web. You may be familiar with our NetServer Web. Basically, PacketScan can sit anywhere on a network, capture all the data, and then send it to our central database. And our central database is called NetServer Web, and it has a really convenient graphical user interface, basically a web-based dashboard that Mike will talk about later, that can do all the analysis remotely. So you can look at the calls, play back the calls, and so on. Okay, so I kind of flew through PacketExpert and PacketScan. Oh wait, let me spend a little bit more time on PacketScan. This is just showing you all the different protocols that we can decode with PacketScan. So all the different protocols, this is actually just a subset, and all the different codecs as well. So when you encode a voice calls, there's many different codecs, A-law, mu-law, and so on. And PacketScan can decode all of these different codecs. So it's very powerful. Okay, so at this point, I'll hand it over to Prasad, and he'll talk about PacketScanPX, which is basically the marriage of our hardware-based PacketExpert and our software application PacketScan. And together, PacketScan is the complete solution for high-speed capture and analysis. So let me go ahead and make Prasad the presenter. And Prasad, you can unmute yourself and feel free to begin.
Okay. Yeah. Thanks, Vikram. So I'll explain about this PacketScanPX, which, as Vikram has mentioned, it is the combination of our already existing and good selling products. It is PacketExpert for hardware level capture, and combined with PacketScan, which does the software level analysis of the packets. So as you can see here, as Vikram has mentioned earlier, the hardware is controlled through a USB 3 interface. So so as shown here, the hardware is connected to the laptop through a USB 3 cable, and the hardware, it supports both 1G ports as well as 10G ports. So you can capture traffic in both 1G on the two 1G ports here, or you can capture on the two 10G ports. So the incoming traffic on both the ports is captured, and we have a 8 GB DDR3 RAM on board within the hardware. So it is stored there temporarily and then transferred over this USB 3 interface to the PC, where the PacketScan software runs. It picks up the packets and does the analysis. So PacketScan, as shown here, it supports all these protocols, right from SIP, RTP, all the voice over IP protocols, then SIGTRAN, and even the wireless protocols, and even ED 137 and 138 protocols. As mentioned earlier, so there is a lot of flexibility in the ports. So we support both electrical as well as optical ports. So here port 1 and port 2 are actually dual interface ports. So they have both RJ45 and SFP interfaces. User can select the mode, whether to operate in 1G electrical or optical mode from the software. And on the port 3 and port 4, it's SFP plus based ports. So you can plug in either you can plug in the appropriate SFP, either optical SFP or electrical SFP there. So this slide shows the what was existing in PacketScan. So we already had a PacketScan product which uses the onboard NIC. So it runs on a PC and uses the onboard NIC which can operate in 10, 100,000 Mbps interface speeds. So because it's a pure software-based solution, so it had some limitations. So it can support traffic rates up to 500 Mbps. Again, depends on the quality of NIC. If it's a good NIC, then it can go slightly higher. And if it's a not so good NIC, then it can even come down. And it has software-based filtering. So the filtering capability is there, but it's software-based. Now, PacketScanPX brings in the hardware capture ability to this PacketScan. So it uses the hardware-based Ethernet capture. So as mentioned, for on both 1G ports means it supports tri-speed 10, 100,000 Mbps speeds and 10G ports, 10 Gbps speeds. So on 10 Gbps speeds, here it's up to 8 GB we can capture on using on wire rate. After that, it starts dropping the packets because we have to transfer the packets to the host PC. But on 1G ports in 10, 100,000 Mbps, the full wire rate is handled because we can transfer up to 2 Gbps speeds on the USB 3 interface. So in addition to the software filtering, we also have hardware filtering. So you can set 2 levels of filter. One at the hardware level, where the filtering happens at full wire speed, and at the software level, which is at the PacketScan level. So this is just to show how so you can say you have a bigger pipe, say of 10 Gbps traffic, and you are interested only in, for example, stream 1, which is 1 Gbps traffic. So you can set hardware level filter and on the 10G ports and reduce the traffic of interest to say 1 Gbps, and then transfer it continuously to the host PC through the USB 3. So that possibility is also there. Okay, so next is how does this PacketScanPX operate in the network? So it basically operates in 2 modes. So this is the first one. This is the port mirroring mode. So here it acts as a endpoint. So you can connect the port, the capture ports, to the mirror port of the switch. And you can capture all the traffic from all the ports of the switch. And another mode is it can also act as a network tap. So here the 2 ports act as a bypass. So they pass the traffic through the 2 ports. Whatever comes in goes to the other port, and vice versa. But this happens at wire speed, both 1G and 10G. But then you can also copy the packets of interest. You can apply filter, copy the packets of interest, and then transfer to the PC for analysis. So these are the two modes. So as shown here, you can tap into 1G or 10G backbone. So the two nodes connected here, they don't notice anything in between, because PacketScanPX acts in a very transparent mode, passing the traffic at wire speed. Okay, so this is how the main GUI looks like. So you can go and select there are different options here. So you can go and select which ports you want to capture on. So PacketScanPX can operate either in 1G mode or 10G mode, not both together. So you can in either 1G mode or 10G mode, you can again go and select which ports to capture on both the ports or a single port, and you can apply separate hardware filters for each port. So this is how you can select the ports here. So it displays what mode it is in, whether it is 10G or 1G mode, and you can select both the ports to capture. And you can also set the capture filter, which will go later. So on startup, so as I mentioned earlier, so you can run it in either 1G mode or 10G mode. Again, for each mode, you can select which the interface type for each mode. So for 1G, you can select electrical. So if you select this option, then these two ports will be active, and you can capture on these two ports. And if you select 10G electrical, then if you plug in the electrical SFPs to these ports, then you can capture on 10G electrical interface. So in optical mode, and again you can select 1G or 10G. So if you select 1G optical, then these two interfaces come into picture. And 10G optical, you can plug in 10G optical SFPs and capture on these two ports. So this way it gives full flexibility on the interface types. Okay, so after selecting which ports to capture on, you can you can go and configure the hardware level filters. So as I mentioned earlier, so there are two levels of filter here. One is hardware level, and other one is the software level. So you can select, you can set hardware filters um, to filter out unwanted traffic at the hardware level itself, then bring into the PC, and then apply further filters at the software level. Okay, so for each port, up to you can the hardware filters, you can apply up to 16 filters. So each filter can support various uh, header fields, like the MAC. In MAC, you can filter on source and destination MAC, the length bar type. Then VLAN layer, you can filter on VLAN ID, and MPLS layer, the MPLS label, IP, the source IP, destination IP, and the protocol, UDP, source and destination UDP, source and destination TCP. Then you can even filter on frame size, and you can filter, and there is also a raw mode filter. Let me go back. Okay, so there is also a raw mode filter here. So in raw mode, you can instead of setting each individual field, you can set raw hex bytes. So you can give an offset. Say for example, if you select 40 bytes, then you can set offset as 40, and then set 120 bytes raw hex bytes and also a corresponding 120 bytes raw mask. So with so you can enable individual bytes to filter. So in real time, it will just go and compare raw hex bytes against the received packet, and then it will apply the filter. So this will be very useful if you want to say capture something in the payload. So say for example, if you want to capture some 8 bytes of the payload, then you can set raw bytes and set the filter to capture if the uh, bytes match whatever you set. Okay, so similarly, the filters are available for 10G ports, same filters. Okay, before I go, so actually in addition to these 16 filters, we also have a group config here. So in group config, you can combine the filters into groups. For example, you have defined 16 filters here. Now you can combine filter 1 and filter 2 and filter 3. So any number of filters can be combined into groups, and many such groups can be combined together. For example, you can combine filter 1 and filter 2, then filter 3 and filter 4, and then you can combine that F1 and F2 or F3 and F4. So that way you can combine to give more flexibility to the filters. So these filters give a lot of flexibility in capturing the traffic of interest. So various kind of traffic can be captured and filtered and captured here. And once you apply the hardware filters, so you can even go further and apply the software level filters, which gives additional flexibility. Okay, so now I'll hand over to Mike, who will explain about the NetServer Web product. So Mike, you can take over now.
Okay, thank you, Prasad. Now, before I go into the NetServer Web, so I just want to point out a few more things about the PacketScanPX. So I think one of the big selling point here is that we're sort of using the PacketExpert to leverage sort of a hardware-based solution. So that lets you capture and process much higher rate, traffic, and do protocol analysis than what you would normally be able to do with just a pure software-based PacketScan solution, right? So we can apply hardware filters to incoming traffic. So even if the traffic is at multiple gigabits per second, we're able to filter that down to the traffic of interest and then have it processed through the PacketScan. So from a sort of a cost-effective point of view, right? It's more cost-effective than buying a full-blown PacketScan HD solution that we have, which is another step above what this PacketScanPX can do. So that thing can do 10, 40, 100 gig of processing. But this PacketScanPX is a cost-effective solution that essentially lets you turn a regular laptop system into sort of a probe system that's able to process high amount of data with the PacketScanPX. Okay, so now let's go into the NetServer system. So what the NetServer system is, it's essentially a centralized database that's collecting traffic that's sent, or the traffic that's collected by these various PacketScan probes that you may have placed in your network. Okay, so the PacketScan, right, as Prasad had mentioned, it can capture and process and analyze on all of these various protocols. So on the IP side, on the wireless side, on the TDM side, we also have protocol analyzers that sort of do the same thing. So it's able to capture, let's say, SS7 traffic, generate call detail records, capture the voice, and it's able to send all of that data into the centralized database, which is what we call the NetServer Web. So the NetServer Web sits in a central location. It runs an Oracle database, and then there's a front-end web-based GUI that lets you access all of the data, look at all of the call records that have been collected. Let's go to the next slide here. So this is the sort of the CDR view of the NetServer Web. So as you can see here, there's an option here for various protocols that we can collect. So anything that's supported by the PacketScan, any of the protocols that can be processed by the PacketScan can be sent to the NetServer Web for sort of further analysis. So we're able to display all of the CDRs in this view. You can sort it by date. Just view today's call or yesterday's calls, or go back to the last 30 days and so on. And you're able to filter on all of these CDRs that you have captured here. So there's a quick filter where you can type in. So essentially, it's an SQL query that you can input, right? You can search for a specific call number, specific calls with different voice qualities, and so on. And the CDR view also lets you look at all of the captured sort of call signaling messages that have been captured by the PacketScan. So if you click into the call flow, you'll see step by step what message was received. You can go into each message, look at the full decode of that message. For protocols that have voice involved, you can also play back the voice that was recorded by the PacketScan system. So it's a very flexible tool. We can use these CDRs to further analyze, the traffic. We can create key performance indicators, or KPIs, that lets you look at sort of the overall network health. And this can all be done in real time. So as soon as the PacketScan probes, collect this data, it's going to be sent to the NetServer Web, and you're going to be able to see all of those call data, right through this web GUI. So this is one of the call flows, as I was mentioning. If you click on that call detail view, you can see all of this detail, message flow, or all the signaling messages for a call. We construct a ladder diagram to show you, exactly where the message was received, from which node, where it's going, and then you can go further into the message and look at the actual decode of this message. All right, so with all the CDRs that we collect, you can generate your own KPIs. So in this case, we're monitoring the MOS scores for different voice calls. So the MOS score first is calculated at the PacketScan side. So as PacketScan sort of analyzes all of the packets coming in, it's constructing CDRs. It's looking at the RTP traffic, giving you all the different statistics for RTP, giving you a MOS score, and all of the stuff that's collected by the PacketScan gets sent over to the NetSurveyor. And from here, we're able to sort of construct your own KPIs. So we have a set of KPIs that we provide out of the box. And then of course, you can make your own KPIs. So essentially that lets you look at all of the sort of the overall network health on a day-by-day basis or hour-by-hour basis. In this case, this is showing you the listening MOS score, right, from on this date here, how many MOS scores were in the desirable range, how many are acceptable, and how many sort of are not in the not good range. So all of this stuff, whatever data is available in the NetSurveyor, you can use that to construct your own KPIs. Same thing for the packet loss data. So we have that information available through the CDR. So all of that is stored in the database, and then you can use the NetSurveyor to generate these KPIs. So this is giving you sort of a another look at the average packet loss, for example, right? How many packets were received, where there's very little packet loss, how many calls had between 1% or 2% packet loss, and so on. Same thing for if there's a call failure, what the reason was. So this is just giving you a quick look at the pass or fail results that have been collected by the NetSurveyor. Okay, so one other thing that the NetSurveyor is able to do is this generate different types of alerts. So based on the data that you receive, you can create email alerts that, for example, send you a daily email that that sort of collects all of the day's calls and shows you how many calls were successful, how many have problems. We can generate a report for you and send that to you over email. There's visual alarms within the GUI itself, audible alarms, and for all of those alarms, you can set the severity. So all of that is sort of, configurable by the user. You can log any of those alarms to a file to look at later. And this is all happening in real time, right? So we're monitoring the network in real time and generating all of these different alarms. So that's a quick view or quick, I guess, look into the NetServer Web. We do have dedicated webinars just covering this topic. So if you're interested, you can look through our past webinars and you should find one on NetServer Web. There's also a live demo of this NetServer Web on our website. If you go to our website and search for live demo, the first link there will give you a live view of a NetServer Web, which is actually monitoring our internal network here. So you're able to play with that and see what you can do. Okay, so now let's conclude or summarize what we've sort of talked about in this webinar, right? So the main product that we're introducing here is PacketScanPX, which gives you Wirespeed capture capabilities at up to 10 gigabits per second. So it's a marriage of the PacketExpert hardware versus plus our PacketScan software. It's going to give you hardware level filtering, which was not possible before with just a pure software-based PacketScan. So it lets you process even more data than what the software version can do, with the help of the hardware filter. And of course, all the data that's generated by the PacketScan can be sent to NetServer Web for further analysis of your of the voice calls and your network. Okay, and with that, we're going to open it up to any questions that you guys may have.
Sanjeev, do we have any questions from the audience?
Yeah, let me ask you a couple of questions. One is this solution portable? And is there also a rack mount version also available?
Yeah, I'll go ahead and answer that one. Yes, it's very portable. Like we mentioned, it's consisting of the PacketExpert, and then a laptop is basically all you need for this solution. The PacketExpert is very lightweight. It's meant to be portable. You can hold it in the palm of your hand. You carry that along with the laptop, and it's a very portable solution. So yes, it is portable. And the second point about the rack mount, yeah, we also have a rack mount version. So PacketExpert itself comes in both a portable version as well as a 1U or 2U rack mount enclosure. So if you need to put this in like a network room or in a laboratory, you can also do it that way. And we have a lot of different form factors we can put this thing in. We can actually stick up to 3 of these PacketExperts in a 1U chassis and 6 of them in a 2U chassis. So yeah, we have a rack mount version and a portable version. And this PacketScanPX, it can come as both. So yes.
Yeah. Next question is, do you have any plans to go to higher speeds such as 100 Gbps?
Prasad, do you want to take that one?
Yeah. Yes, we do have a lot of plans. So one plan is the next generation of PacketExpert hardware that will support anywhere from 10 Mbps up to 25G. So that is 10, 100,000, 2.5G, 5G. That is Mbps T, then 10G up to 25G. So that is in the pipeline, and it will be available sometime next year. And another product which is something similar to PacketExpert, and that will support 40 and 100G rates. So even that is, we are actively working on that, and that may be available maybe in the first quarter of next year. So both those products are very much planned, and we'll be doing that.
Yeah, we have another question. Is it possible to use PacketExpert such as capture and with the capability to store or send the PCAP capture to a PC and analyze with other sniffers such as Wireshark?
Yeah, that is possible. So PacketExpert on its own can record traffic and save it to a PCAP, and then you can open the PCAP at a later time and analyze it in with whatever protocol analyzer you want, either our PacketScan, or if you want to use Wireshark, you can also use Wireshark because we save it as a PCAP file. So yes, that's absolutely possible, but keep in mind that in that scenario, what's happening is that PacketExpert is recording the traffic, and at a later time, you are doing the analysis. You're opening the file at a later time. Whereas this PacketScanPX is in real time. So all this Wirespeed capture and analysis is happening in real time. So that's the advantage of using this PacketScanPX is, first of all, PacketScan is more powerful than Wireshark. I love Wireshark, but in terms of, especially in terms of voice call analysis, PacketScan is much more powerful. It can do all sorts of things like voice quality analysis and so on. So yes, you can use Wireshark, absolutely. PacketScan can do more for you in terms of the protocols and the analysis, and also we can do all this in real time with this whole PacketScanPX solution, where the PacketExpert is sending the data in real time to the software for analysis. But yes, to answer the question, yeah, you could record all the data and then open up the packet capture at a later time in Wireshark. That is possible.
Yeah, another question is, does the NetServer Web software comes with PacketScanPX?
No, NetServer Web is like an additional option. You don't have to purchase NetServer Web. It's an additional option, and there's a couple different variants on NetServer Web. If you need like a full-blown high storage solution with a database, and hundreds of gigabytes of storage or even terabytes, we offer that. But then we also offer like a light version of NetServer Web that's just simple software that you can put on the same computer that you're running PacketScanPX. In that case, you would buy the PacketScanPX and the additional NetServer Web Lite software. But to answer the question, the PacketScanPX is a separate solution from NetServer Web. NetServer Web is like an additional option you can purchase to complement the PacketScanPX solution.
Yeah, one last question, which actually is asked by several customers. Do we have a handheld version of PacketExpert which can support the PacketScan?
A handheld version of PacketExpert, meaning like a tablet.
Right.
No, we do not have like a tablet version of PacketExpert. All of our products you configure from a PC, whether it's a laptop or a desktop. All of our products are controlled by a Windows 10 PC. Yeah, we don't use touch screens. We don't like touch screens because it's the screen is small, the buttons are small. It's actually much more convenient. What we've seen with a lot of our customers, it's much more convenient just to plug it into a laptop and have a nice comfortable screen and keyboard to work with. So we always prefer plugging it into a laptop.
Okay, we have one last question.
Sure.
Can you capture 1 gig and 10 gig links simultaneously?
Prasad or Mike, do you want to answer that one?
Yeah, no, not simultaneously. So it works either in 1 gig mode or 10 gig mode. So you have to choose from the software on software startup. So yeah, so it's either 1G or 10G.
Yeah, just to add to that, you know, if it's a 10 gig link that you're capturing across, then you would open up the software in 10 gig mode. Of course, the actual bandwidth that's flowing on that link may be much less, right? It could be, you know, 1 gig or even less in terms of actual traffic flowing on the network, and that's no problem. But yeah, if it's a 10 gig link, you open it in 10 gig mode. If it's a gigabit link, you open the software in 1 gig mode.
Yeah, thank you, Vikram. Thank you, Prasad. That's all I had.
Okay, all right. Thank you everybody for attending this webinar. Thank you, Mike. Thank you, Prasad. Thank you, Sanjeev. Like I mentioned before, this webinar will be made available on our website. So within the next day or two, feel free to check it out. Also, if you haven't already, please subscribe to our newsletter. We always put one out every week, giving you the latest product updates and software updates and so on, and all the different news happening in the world of telecom. So please contact us at any time for any additional questions. Our email address is right there, info@gl.com. And if no further questions, please enjoy the rest of your day. And we look forward to hearing you soon. Thank you very much.